Okay, so hopefully that won't slow down my computer too much as I'm recording it. So I want to thank all of you for your interest in Homer. Um, we may have 25 different people connected right now. It's quite a few people. And there's several people who wanted to connect, but I can only support 25 connections. So about 5 or 8 people couldn't make it. So hopefully they can make it next time. I'm sharing my screen right now. Is everyone able to see my screen? Or I guess speak up if you're unable to see my screen. So I gather that means everyone can see my screen. Um, Perfect. So, because of there's so many people on the line, I just encourage you to mute your line. And of course, if you want to speak up, then unmute it. Um, if everyone's line is open, we may end up having a lot of background noise that will make it difficult to communicate. But please feel free to speak up anytime if you have any questions. But just in between those times, maybe you want to mute your line. So a number of people sent me questions, and I tried to organize them into some format that we could try to cover over the next hour. So I created this document here with the questions. So I thought I'd just go through these one by one, and certainly uh, ask questions along the way as we're going through this. So the first question I decided to look at was from Maria, who asked, is there a way to remove channels in an automated fashion within Homer based on the interoptoid distance? So no, there's not. And what a great thing. This will be easy for me to add to one of the functions we do have, which is prune channels. So I'll show you how we use that. And then over the course of the next few days, I think it'll be quite easy to add interoptoid distance to this. And then I'll update Homer so that that functionality is there. So I just want to remind you of how you can do remove channels. So I have this one data set here. I forgot to check if these are all available online, but forgive me, I forget what's available online, but I can just take you through this anyways. So I'm going to run Homer on this one data set we have. This was a small probe that was placed over the motor cortex of a subject who was doing a finger tapping task. It's a very good data set. It has short separation measurements and long separation measurements. If we look at the processing options, I've added this prune channels function in here, and this can prune channels based on a data range or a signal to noise ratio, a threshold. So basically, if the signal's not within this range, it would be excluded. That channel would be excluded. Or if the SNR is not greater than 2, then that channel would be excluded. So based on that question, what I'm going to do is add another parameter here, which is the source detector separation range. And so if the separation is not within that range, it would exclude the channel. So I've run this on this data set, and you can see it actually excluded this green channel. You can see because it turned yellow, the background, rather than gray. So that means it was automatically excluded. And if we look here, basically we can see it was automatically excluded because the signal was too low. So it's if we zoom in here, we can see the signal's less than, on average, it's less than 1 times 10 to the 4. And that was our range, was it had to be greater than 1 times 10 to the 4 and less than 1 times 10 to the 7. So that channel is automatically excluded. So I suspect for Maria that actually the present functionality of excluding based on a signal to noise ratio or on the data range may be sufficient for you to meet your needs. But in the next few days, I'll add this functionality for you and others to use. Any questions about that before I move on to the next question? Okay, the next question came from Erin, who asked, "Would like to have some more discussion about export files, and it's not clear how these are generated." So uh, I can use this same data set I have here, and the way I use this, and there may be different functionality, so Aaron, speak up. Um, the way I use this is I will right click a trace, and if I right click the trace, I can export this trace or export all visible traces. So I'll just say all visible, and then it asks me for a file name. So I'll save it as foo. And so it saved those traces. And so I can go in and edit, open up that text file we just saved. And this is the format. And I think it should be self-explanatory. You've got your time, the channel, source and detector, oxy, source and detector, oxy, and then it's repeated for deoxy. And then it's output in a format that is a plain text file that's tab delimited, and this should open up into Excel, I think, quite easily. So that's how I use the export functions. There may be some historical stuff. Yeah, I think maybe under the file menu. And to tell you the truth, I don't know how those work. Um, I haven't looked at those, so I'm not prepared to talk about those. And those may not work actually well. So I'll make a note to look at that. But what I just showed you about right clicking on the trace, would that meet your needs?
Yeah, I actually didn't know that you could do that. So I
Yeah.
only knew about the ones in the file menu, and so I was doing the export, and they seem to do something reasonable. But there's a table at the top that says, um, I think excludes criteria or something, and then there's
Yeah.
a table below.
Yeah, I
Um,
understand. Yeah, okay, I made a note to go look at those. I think those are kind of there with some historical annoyance.
okay.
Wait, somebody, we have a bad background, so I just want to remind everyone to mute their lines unless they have a question. I mean, I can mute everyone, but then you can't ask questions.
Okay, so that I just had a question. So that will just basically export exactly the plot that you see there, and the values, no processing done to it, just whatever was done.
That would be good.
um, Shoot. Somebody's got background. Please mute your lines unless you have a question. All right. So, Aaron, what was your question?
Oh, just clicking on that will export exactly what is shown in that plot, just so you have the numbers.
Yes. Yes.
And okay. Um, and so if you were doing, let's say you were using Homer, it's good for visualizing, and then you want to actually do some statistical tests or something like that. Do you use that, or is there anything else that you use?
So, if you want to do right, so you can, if you have, you can export session results here, run results, group results, and then you can bring it into your own favorite statistical analysis package to do your analyses. The That kind of second level statistical analysis of group results and such is still a works in progress, really, for Homer.
Mm-hmm.
So hopefully in the future, those features will advance. But at least now, you're able to kind of export the results, um, and bring it into your favorite analysis package. And that it's kind of ringing a bell. I think that's under the file menu here. The goal here was to try to export a lot of results efficiently for you, but that's
Mm-hmm.
really still a works in progress. And so I need to go back and revisit that to see how well those work.
Okay.
Yeah, but
Thanks.
for sure, if you do it, by right clicking the traces, subject by subject, that will certainly work for you.
Okay. Yeah, I didn't even know that was available.
Yeah.
So.
Okay. Super. Yeah, I'll make more notes about that.
Right click. That'd be fine.
Okay. So the next question from Vincent. Okay, so how to make a correlation diagram between different channels. Um, Vincent, I'm curious, why are you interested in that? Maybe Vincent's not here, or maybe he's muted. Vincent is here using a web viewer. He didn't call in. Okay, so I guess he can't talk. Well, I'll show anyways. We do have this function um, which will calculate the cross correlation and between channels, and it does this on concentration data. And once you've processed your data, you can click results, and it'll actually pull up these two plots for you. That's going to show you the cross correlation between channels. So you can see source A, detector 1, which is corresponding to this channel. You can see its cross correlation with every other channel, color coded. And so this has some interest to see what the physiological correlation is across channels. You'll often see that oxyhemoglobin has strong spatial correlations across channels. Deoxyhemoglobin will have less spatial correlations. This is the types of things people would look at if they're looking at um, resting state functional connectivity. They would look at these cross correlation patterns. Of course, if you're looking at the resting state functional connectivity, you have to do some pre-processing first because you want to remove the common mode to all the channels. So maybe that's what Vincent's question was kind of getting at. So this functionality is there if you want to explore it, but it's still kind of in its infant stages. It's not used in many other functions at the moment. Continuing along, Ingo, excuse me, maybe that's how you say your name, asked about working on artifacts before or after conversion to optical density. So I always do this on optical density data. So I'm going to switch to another directory, whoops, where we have motion artifact data. So this was data we recently published where we had the subjects purposefully moving. And so we had them doing many different types of movement at a regular basis, and it was introducing lots of motion artifacts. So if I look at the processing stream, I work on these data. I first convert intensity to optical density. And this processing stream, I kind of put in all of my favorite motion correction methods. You can do just a PCA filter on all of the data, on the optical density data. I use this only really on infants to remove their motion artifacts. Um, and that's because in infants, oftentimes motion artifacts will dominate the variance in the data. And the PCA filter is very good at removing components from the data that dominate the variance. But if there isn't much motion, then this PCA filter actually starts removing the evoked activations of interest. So you have to be really careful of PCA filter. Then we can identify motion artifacts by channel and use, then we can use spline motion correction or wavelet motion correction or a targeted PCA a motion correction. Um, right. So I can go through this if people are interested. I guess Inga's question I addressed, which is we do the motion correction on the optical density data.
Yeah.
Well, go ahead.
No, I just said yes.
Yeah, okay, great. Is anybody interested in seeing some of how these motion correction procedures work?
Yes.
Yeah.
Yeah. Okay, so I think there was another question about how we set. Was it Amanda? I think asked questions, a lot of questions about how we set these parameters. So, the amplitude threshold would be identifying motion artifacts if in this case, the optical density changed more than 5 over half a second, right? So basically, if I don't want to identify any motion artifacts, I would set these values to be very large. Um, Also, if I don't want to perform any motion correction, I put 0 for PCA filter. For spline, you put -1. For wavelet, you put -1. And that's explained. If you mouse over the help, that will explain just to put -1. So if I see you're making a lot of noise, I mute you, Vincent. That was you. Um, so you can put -1, and so it won't do any motion correction. This is the targeted PCA, is a method we recently published. I'm not going to do any motion correction there. So if I run this now, you can identify the motions that basically exceeded either 5 amplitude threshold or 50 in terms of standard deviation. Um, I like to use, 5, actually, these are default values. 50 and 5 is basically you don't want to find any motion artifacts. So the only reason we found any motion artifacts here is because these were purposeful large motion artifacts. I would typically use much smaller values of, maybe 0.5. Look at optical density. So 0.5, let's run that again. And see, well, that's curious, we'll find the same. Okay, well, so this is looking at the optical density. You can see these motion artifacts that have been identified. Let's do a targeted PCA now on this. And I'm going to say, basically what this is going to do is these epochs of data that have been identified to have motion are now we're going to perform a principal component analysis only on the data with the motion artifacts. That's as opposed to this PCA filter up here, which would do a PCA filter on all of the data, right? So in that way, this one could actually remove physiology of interest, whereas down here is only with the motion correction, it's only operating on the epochs of data identified to have motion. So in that case, it's only going to remove, the variance during those epochs of motion. So it has much less chance of removing the physiology of interest. But it does require you to objectively identify those motion artifacts, right? But this procedure of setting this amplitude threshold, right, or this standard deviation threshold seems to do a very good job of objectively identifying those motion artifacts. Okay, so if we set those parameters and run this again, you can see what impact that has. Maybe I can copy this figure first. So we can make a comparison, right? So this is what it looks like before we do the motion correction. If we run again, so there it is after the motion correction, right? So you can see really quite a dramatic difference in how well that targeted PCA has really removed all of those spikes and made the data much more smooth. So presently, that's actually my favorite motion correction method. The spline also works very well, and the wavelet works well. But in a paper we published recently, you can see some discussion we have comparing this targeted PCA with spline and wavelet. Any more questions? Any questions about this before I move on?
Hi, actually, I wrote a question in the
Yep,
chat.
sure. Oh, sorry, I wasn't okay in the chat. Let's see. Uh, okay, you asked, when a stimulus is excluded because of an artifact, is all the data excluded from the analysis for that stimulus? So, right. Um, this example doesn't show it, but in the processing stream, there is a function that will reject stimuli if it's too if there's a motion artifact within some time range of that stimulus, and the user gets to specify that time range. This particular example doesn't have it. I could bring up another example that has it, but I think your question is asking, would that reject the stimulus for that channel or all channels? So basically, it's going to reject the stimulus for all channels. People have asked us in the past whether or not it could just reject it for the channels on which had the motion artifact, but that creates kind of a bookkeeping challenge. And I mean, it's a bookkeeping challenge we can handle, but then when it comes to writing your paper, you have an even greater challenge of describing how for different channels you had different number of trials. And so given essentially that challenge and nightmare of describing in your paper why you had different numbers of trials for different channels, and in my experience, reviewers won't be very happy with that. We've kind of just left um, the Homer functionality that if there's a motion artifact on one channel for one trial, we're going to remove that trial for all channels.
Okay, thank you.
Yeah. Any other questions about motion artifacts or motion correction? Let's see. Amanda had many questions. Let me. So Amanda, looking at your questions, are there any that we haven't addressed yet? Numbers 3 and 4. Okay. So number 3 is when doing a processing stream, what is the best practice for observing effects on different? Excellent question. Okay. So I think Amanda's basically asking, should you optimize the processing parameters channel by channel to get the best results, or use the same processing options on all channels? And I've never been asked that question before, but I've been asked the second question, which is, should you use different processing options subject by subject, or use the same processing options for all subjects? And I think different people have different philosophies on this. The argument I've heard that makes a lot of sense to me is to ensure that you report your data in the most objective way possible, that it's good to use the same processing options on every subject. And so if you're using the same processing options on every subject, that would also kind of mean that you're using the same processing options on every channel. And that really ensures that you don't introduce any bias into the analysis of your data. If you start choosing processing parameters that give you the best results subject by subject or channel by channel, then essentially what you really run the risk of doing is biasing your results and interpretation of the results. So I hope that answers your question. Yep. Okay. So moving along, Ojwal asked about converting ETG 4000, which is Hitachi, I believe, and Nearsport, which is maybe Nearx, into Homer compatible format. I don't have such data files. Um, Other users have supported on the webpage uh, the ability. What happened there? The ability to do those conversions. So if you go to homerfnears.org and the FAQ, um, you can actually see information there about converting to Hitachi files to Nears files or Nearx files to Nears files. Um, so I don't really have any expertise there, but other users certainly have expertise there. Um, if you have any questions about the Nears file format, that is described in the documentation, so you can find the documentation online. If you go to documentation and click the Homer's Users Guide, on page 4, that Nears format is explained. It's a MATLAB format. It's pretty straightforward. So if you have any questions about that, or just email the email list. Also, questions about the specific converters. Um, those were written by people like Rebecca Dewey wrote one of them. Rob Cooper wrote another one. You can check out their project pages with these links and email them directly if you have questions about that. So I hope that answers your question. So GLM. So there's a question about GLM. I want to come back to that. So over the years, we've have had an evolution of doing GLM with Homer. At the beginning, it was only doing block averages. Then we started to add GLMs, and we had multiple GLM functions. But now it's really kind of solidified down to one function, and that one function is capable of doing everything. So that one function we like to use is this one, this GLM href drift ss, or the script. Let's see, it's actually this function here. So if you like to read MATLAB code, you can look at this function here. It actually does everything, so it's been really quite nice how it's evolved over time, and gives you options to do many, many different things. As a result, it's kind of becoming a complex function, but hopefully the help is clear and provides references on all of the options. And it only has a few basis functions. Um, we were just asked to add the AFNI basis function, so we added that. If there's any other basis functions you'd like to see added, you can just email me and we can discuss adding that basis function. Um, I suspect that many people are interested in this question, so I could spend some. Whoops, I lost my MATLAB page. I could spend some time um, going through examples of different GLMs if people would like that. So I pull up this function, um, and basically you set the time range for the href. So I'm saying -2 to 15 seconds. So there's our evoked response from -2 to 15 seconds. You choose the solve method. So this is a new feature that's appeared recently. The solve method. Traditionally, we were using ordinary least squares, which is described well in the Nears SBM paper. The reference is provided there. But Ted Huppert and his team, they recently published a paper. The citation is there, using an iterative weighted least squares method, which looks very promising to overcome issues in the assumptions with the ordinary least squares method. Basically, the assumptions are that all of the data are correlated, or that the residual in your model fit would not have any correlations. But in fact, it has strong correlations, your residuals. So the model never fits the data with the residual that is pure random noise. As a result, kind of the noise estimates you get with the ordinary least squares are going to be incorrect. So what Ted Hubbard developed was a method that would pre-filter the data so that the residual of the GLM would actually be random. And his paper describes very nicely the improvements offered by that. So you now have the option here. So we incorporated Ted's algorithms into this GLM. So you can either choose ordinary least squares method or the iterative least squares. So we default to ordinary because that's what most people do. And also the iterative one that Ted has developed is slower. So what you might do is just to kind of explore your data, you use ordinary least squares, but then when you want to get the proper statistics, you would then switch and use the iterative weighted least squares. You then get to choose your basis function. I'm using, so we have 4 basis functions you could choose right now. The first one is essentially just a series of Gaussian functions. So it really has no assumption about the shape of the HRF. I could change this to basis function 2, which is going to be a modified gamma function. So that this is going to impose a specific shape for the basis function. So I have to input some parameters to define this shape. So I have a delay. I'll put in a delay and a width and the stimulus duration. So we can run this again. And now you can see this doesn't really have any specific shape to it. But if I run again with that basis function, we now get a very specific shape for the evoked response. Right. So that's kind of what you get when you use different basis functions. Looking through here, we also have what is the if you have short separation measurements, you can actually do a short separation regression to remove systemic physiology from the longer channels. Probably by this point, you all have read papers that describe these methods. People are more and more finding this is very useful on adult data to remove that systemic interference from the scalp. So here we're saying source detector separations less than 15 millimeters are available for doing short separation regression. We then have a flag that will indicate which short separation regression method to use. So there's 3 different methods. You can either perform the short separation with the nearest channel, the channel with the highest correlation, or with an average of all short separation channels. And you'll find reading different papers, people use different methods of those. So you're able to specify which method. And the effect of that short separation regression, if I do plot probe, basically you can see, on this, these short separations have no evoked response, right? Because they've regressed themselves out. They have no signal left anymore because they've been regressed out. If I didn't do a short separation regression, so let me put a 0 here. So basically it's not going to do any short separation regression. I run this again. You can see these short separations actually do have some measurable, evoked response, right? So that's just systemic interference that is correlated with the presentation of the stimulus, right? So by actually regressing that out, you should increase this statistical significance of of your estimated evoked response. So you also have a drift order correction. So this is a polynomial drift correction that you can apply. I like to use a third order polynomial drift correction. You can even do motion correction as part of the GLM. Some people like to do this. I find it actually doesn't perform as well as using either a spline or wavelet or a targeted PCA. So I don't prefer to use that. One thing to note is if you want to use Ted Hubbard's iterative least squares method, for the solving the GLM, we make a note here. We suggest that drift order be set to 0 because actually that pre-filtering they perform actually removes drift from the data. So you don't want to do drift correction at the same time as it will produce spurious results. So this one function has a tremendous amount of functionality. I can develop the FAQ and help pages more about this if any of it is unclear. So just send questions, to the list server if you ever have questions about this. Before I move on, any more questions about the GLM? Okay, I can move on to AtlasViewer, but before I move on to AtlasViewer, I just want to make sure nobody has any remaining lingering questions at this point about Homer. Okay, Amanda just put a question up on the chat. Back to my question about different subjects and channels. Since using the same processing stream parameters for all, does it matter which file and channel you start with and use as a basis for the rest of the group? No, it doesn't matter. So we actually have this option here, copy options. So if that's clicked, basically what happens is as you move from channel to channel, it's going to copy the processing options from file to file. If that's not clicked, you have to manually go in and change the options for every file. So what you could do, of course, is you can try different options on different files and get a sense for what set of options you like to use. And then once you've decided by looking at all the files individually, then you apply that set to all of your subjects. Okay, Aaron asked if there's a way to show two different conditions on the same plot. And no, there's not. So what you could do right now is copy the current plot. So you've got that result for one condition. You can then go down. This example doesn't have two conditions, but I think you get the idea. You could then go down and select your other condition, and then you'd be able to compare them side by side. I agree it would be good for comparing if you could put the conditions on the same plot. I can see how it would be done, so I'll make a note of that. I'll make a note of that. Okay. Any other homework questions? Okay. James is asking, or James Madison University is asking, are the href plots still auto-scaled only? We have this function here, fix range. So, sorry, I realize maybe many of you are using the executable version, which we haven't updated in a while. So the executable version, of course, doesn't have all these features. I need to release a new executable version. I hope to do that as soon as possible. But so once that is updated and you're using the executable version, you'll see this feature. If you're using developer's version, you'll see this version as this feature already. But you can fix the range. So if you click this, it will now fix the range, and as you switch from channel to channel, it's going to use that same range. If that's not clicked, it then auto scales. So that feature was requested, and we finally got around and added this feature so that you could fix it to facilitate comparisons across channels. Okay, I made that note. Okay, yeah, hopefully we'll get this done in the next few days. It's a little bit painful creating the executable, so forgive us for the delay. Okay, maybe I'll move on to AtlasViewer at this point. Okay, so let me close that down. I think so. AtlasViewer is still quite new. I think more and more people are beginning to use it. Its functionality, I find, is quite robust. So I'm very happy with how well it's working. There is no executable version for it. That's been presenting some challenge to us to actually create within MATLAB. So we're working on that, but there's certainly the MATLAB version is available. So I think Teresa had a number of specific questions about AtlasViewer, so maybe I'll start with that. So Teresa was asking about the digitized points. So this first example, let me open up this function, this dig points. If you have any digitized points, you could use any of your favorite devices to getting 3D coordinates on your subject. All you need to do is create this text file. And the coordinate system doesn't matter, but the units, it's really preferable to use units of millimeter. So whatever device you're using, make sure you understand what the units are. And then if you can convert it to millimeters, all you have to do is create this text file. And you give the coordinates of these 5, 10, 20 locations, NZ, CZ, IZ, and right and left ear positions. If you specify those 5 coordinates, you're then able to register the atlas head to your subject. And then once you've done that, if you've digitized sources and detectors, you can give the coordinates of those sources and detectors, and then you're going to be able to view them on the registered atlas, right? So I can show you how that's done. If I run AtlasViewer now, I think, if I run AtlasViewer, so I'm just going to say no. So AtlasViewer, it recognizes that those digitized points are there. It loads them up. So there I have the digitized points. What I want to do first is register the atlas to the digitized points. So this is actually looking at those 5 landmark positions and registering the atlas to those 5 landmark positions and doing the transformation, converting the atlas now to the subject space, right? So here's the result. We can show the reference points and we can show the digitized points, and we can zoom in, and you can see yellow, that's the digitized point for NZ, and there's the atlas position for NZ. So they've been closely registered. Likewise for AR, it was close. You can see it there. AL is close. IZ, you can see on the back of the head, is closely registered. And on top of the head, we have CC. It's closely registered as well. So now, the atlas has been registered to the subject. We also had digitized the positions of the optodes. So here are all the optode locations. We can show them as sources and detectors. So we have the sources are red and the detectors are blue. You can show the measurement list, so you can see where your measurements are. You can see several of the points are kind of not on the surface of the head. And oftentimes when you're digitizing the optode locations, you're going to digitize the top of the optode. which is going to be a few millimeters off the top of the head. So you really want to register the probe to the surface of the head. So that pulls it now to the surface of the head. And once you've done that, there's many useful commands you can do now. You can project the channels to the surface of the cortex. So I just press that. And so it's actually using functions developed by a Dan, and it's projecting now all channels to the surface of the cortex. And this atlas has been registered to the MNI coordinate system, and labels the labels on the MNI coordinate system. So you're able to then to find for every source detector pair what is the MNI coordinate for that channel, and what labeled part of the cortex does that channel actually reside over. So this is actually very useful for reporting your results. You can say, this channel with source 1 detector 1 was over the frontal inferior cortex, or source 1 detector 5 was over the left precentral cortex, with those MNI coordinates. So that really facilitates comparison of your results with results from other groups, and kind of using those MNI coordinates is still a standard, with MR, and is and more because of tools like this can become a standard for FNIRS studies. So looking back at Trace's questions. So Trace, help me out with your questions.
Yeah, I think that definitely covered the question about the DigPoint file, about the units that it's meant to be in. Just trying to remember exactly what I. Oh, when I was downloading the CSV, I noticed that there's a couple of different atlases. It looked like there was like newborn ones and things like this, and I just tried to briefly mess around with how to change those, and I was curious if you could maybe touch
Sure.
on how you might see something different.
Yep. Great. So we can actually go in and you can change Atlas. So I click that, and Colin is our default Atlas. Rob Cooper has and Sabrina Brigadoy, they've created this set of neonatal head models, which is a paper that's under review. So this is not publicly released, although Rob wanted me to go ahead and include it in AtlasViewer at this point, but we haven't publicly announced it. So you can see that it's there, and it's very impressive. These are all gestational age. It's not how old the infant is. This is from gestation. So these are all mostly premature infants. So I could, I open up a 40-week brain, and I would just say open, right? So now it's going to use the anatomy of that infant. It's going to be a little bit wacko, because, of course, the digitized points I have are for an adult, but let's actually, it crashed. Interesting. So that crashed. So that, no doubt. Well, what's important is we have now created the ability to add more atlases. And so as more people publish atlases that can be used with mirrors, it'll be quite easy to incorporate them into the package here, to disseminate them to all the AtlasViewer users. We've also created the possibility so that you can use your own anatomy. Let me quit out of this for a minute. So, we have a nice example here. Here's a 3-year-old. This is something John Spencer was using. So if you have your own MR anatomy, you can create this subdirectory called anatomical, and we can look in anatomical, and it has all of these files in here. This is I will create a fact page that will explain how these files are created. Um, I don't think that's up on the webpage yet, but it's fairly straightforward. If you have a segmentation of MRI and you've created surfaces of the head and of the peel surface, it's actually pretty easy to create your own set of files that then AtlasViewer will recognize. If I run this, it's actually going to use, you know, that subject specific MRI, right? So this is the MRI of a 3-year-old, and the digitized points. This should work, right? So now we've registered everything, right? So Atlas Viewer will allow you not just to use atlases, but you could use your own MRIs. You can see the quality is not as good because um, the quality will depend on how well you're able to segment your own MRIs. And I think most people aren't able to segment them well and create, beautiful surfaces of the brain. But if you are able to do that, you'll get a very nice subject-specific atlas if that's what you like to do.
Cool. Those look really awesome.
Yeah, yeah, I'm very happy with the functionality, and it enables you, the user, to use really any anatomy you want. Of course, the anatomy is only going to be as good as your MRI and how well you segment it. So, Tracy, were there other questions about AtlasViewer? Oh, is there a way to is there a way to restore your session? That's a very important question.
Yeah, and I'm not referring specifically to like saving the session at that point.
Just
a matter of like, I feel like I've tried to do like just messing around with things, and it's probably just lack of experience, and somehow mess something up, and I try to open AtlasViewer again in the same directory, and I can't see the atlas, or something happens, or I get an error, and I just want to get back to like where it was to begin with, I guess.
I don't understand. So first, just for everyone else, you can save your viewer state, and that way, if you save that and then close it down and reopen it again, it will come back to where you were. But so you're saying you're messing around, and you aren't able to get back to where you started.
Yeah, so I think it might have something to do with just having like dig points that aren't very good or something like that.
Yeah.
So it may just be something that I can't quite reproduce. So
Yeah.
if I do reproduce it, I'll send a
Yeah.
note specifically.
Yeah. Great.
Thank you.
And this was still, this is still an early version. So we've been making a lot of updates, and it's getting more and more stable. So some of it may just require, starting in a fresh directory to make sure there's no historical stuff messing up the results.
Okay, that's a good tip. Thank you.
Yeah.
I had a question along those same lines.
Yep. Go ahead.
Yeah. Is it the case that you have to convert from the .ezs files to a digpoint text file? And is there another way of creating that text file without using the EasyMapper?
Yeah, that absolutely. I mean, that EasyMapper was a tool that Chin Fang developed, but hasn't been very. I think only about 3 people use it. So,
Okay.
The important thing is dig points. This text file. All you need is that text file. So you can use any digitizer you like, and the digitizer will give you 3D coordinates. Then all you have to do is create this text file and put the coordinates of the reference points into this text file. And the coordinates should be in millimeter units. And then you can give the coordinates of your optodes that you obtain from whatever your favorite 3D digitizer is. So does that answer your question?
Yeah, I think so. Does the acquisition GUI need to first take the reference points, IZ, NZ, etc., and then sort of reset the reference before you collect your optode locations. Does that make sense?
I think so. So I think I understand your question. The AtlasViewer. Okay, let me shut it down and go back. Keep losing what directory. Let's see.
I guess that's more of a question of the Polhemus acquisition GUI.
Well, so I'm not at all talking about how you acquire your 3D points, right? So I'm only talking about AtlasViewer. AtlasViewer doesn't acquire 3D points. So I'm assuming you've got your 3D points and you've created this dig points text file, right? So forget this EZS file. You don't need that. All you need is this file, right? And so assuming you've created that file, you can then run AtlasViewer and those are the digitized points. And then all you say is register Atlas to dig points. Is that clear?
Yeah, I'm still stuck at the previous step then of
Right.
acquiring those.
How
those
you
points.
acquire, right.
Okay.
So that is not part of AtlasViewer. So sorry. I that's outside of today's discussion.
Yeah, sure. Then I guess just to clarify though, the dig point text file won't reset. How do I explain? Like reset the reference of the head based on those landmark points, Nazi, Ninian, etc.
So that dig points,
Like is that step done in? Mhm.
the dig points text file defines the coordinate system, right?
Okay.
So I keep losing where I want to be. There's the text file. These ref5 reference points and those coordinates define the coordinate system. So the atlas is actually transformed into that coordinate system.
Right.
Yeah, sorry if that's confusing. You can email me afterwards if maybe I can try to explain it more.
Okay. No, that's great. Thanks.
Okay. So I saw Matthew asked a question online, which is a great question. He said, basically, does AtlasViewer presently allow you to essentially view any Homer results? And we're working on achieving that, as soon as possible. And I hope that will come out. I hope that will come out soon. It's probably still going to take us a few more months. But the plan is basically you're going to be able to take your results from Homer at the subject level or the group level, that you're going to be able to actually reconstruct images of those results and view them within AtlasViewer. This image recon window here, you can see is actually a step in that direction. So we've started to do that on the AtlasViewer side, and on the Homer side, we've had to make some structural changes, at the foundation of Homer to really facilitate this interaction between Homer and AtlasViewer. So we hope that will happen soon. Which actually brings me to a request I'm going to make of all of you. I've actually used a P41 NIH Center grant to kind of support these activities over the last several years. That effort is, and on FNIRS is actually coming to an end. So I'm pretty much running out of funding to officially support this stuff. I, of course, want to keep doing it because it's a great tool for the community and it's good for my group as well. But I need to raise more money so we can continue developing these tools. So there's actually a specific grant mechanism at NIH I'm going to apply for in June. for which I need testimonials from users that this package is useful for them, uh, and that the continued development and maintenance of the software and training is useful to them. I'm going to be submitting that June 1. So if you're so inspired to send me a testimonial, I'd very much appreciate it, and I can include it in the application. I mean, also once I have, I think any sort of brief testimonial, short email is sufficient. I imagine also be good to have some longer testimonials when I get specific feedback from the program people. I'll email it out to the Homer list to request more testimonials. So thank you for any support you can provide. So this has been an hour. So thanks a lot for all the questions, and I look forward to holding another training session soon. And I very much enjoy all the discussion that people are having using the list server, the email list server, and very much appreciate that others are providing answers as well. So it's really growing a great community. So look forward to talking to all of you soon, and I hope to see many of you in Montreal in October at the FNIRS conference. So bye.
Thank you.
Yep.
Thank you, David.
Yep. Bye.
Thanks.
Okay. Bye.
Thank you.
See that one group's using